YouTube. In this video we're going to discuss the vertical line test to see if a relation is actually a function. And what this is, it's just a nifty way to look at the graph of a relation and be able to determine whether or not it's a function just by looking at the graph. Okay, so as kind of a lead into this, what we're going to do is we're going to start by looking at a couple of relations. We're going to make these up here. We say A and B. Okay, we say let's let relation A be some mapping of inputs or domains onto ranges or input onto output here, and we'll say we've fill this up with some numbers. We say 1, 2, why not 5? We'll make this negative 2, negative 1, 0, 1. And we have some relation here where 1 maps onto negative 2, 2 maps onto negative 1, 5 maps onto 0, and 5 also maps onto 1. And then in our second relation here, we say we've got some input-output mapping. Let's go with, how about 1, 2, 5, negative 2, negative 1, 0, 1, but this time I'm going to have, how about 1 maps onto negative 1 and 2 maps onto 0, and we'll have 5 map onto 1. Okay. So anyways, we have our couple of relations here, and what I want to do is I want to represent these graphically. And of course graphically mean that we're, we have our x's mapped onto some y's here. It means that we should have some pairs of points that we can put on these graphs, or these number lines down here. So we say, all right, in our first relation, if we were to graph it, it looks like we have 1 mapped onto negative 2. So we'd say the point 1, negative 2 is on the graph. This means we'll go right 1 and down 2. So we say, okay, so this point is on our graph. So we say 2, negative 1 is also on the graph. So 2, comma, negative 1. So we'll go right 2, down 1. We say this point is on our graph. We say, all right, 5 mapped onto 0, so we say 5, 0, also 5, 1. So if we go out to 5, 3, 4, 5, okay, that's 5. We say 5 mapped onto 0 and 5 mapped onto, we'll call this right here 1. So kind of hard to see because everything is acting up a little bit on my Photoshop. But anyways, we have our 4 points here in our relation. We say if we look at this second relation now, we can go ahead and draw these number lines in. Again, and we say, all right, in this instance, we said 1 mapped onto negative 1, so we go right 1, down 1. We say 2 maps onto 0, so we go right 2, up and down none. And then 5 maps onto 1. So again, out at 5, we get up at 1. Okay. The difference between these two instances I want everybody to see is essentially this. And when you look at the first case here, we say, well, this, if you think about it, this is not a function. Okay, this is only a relation. And the reason why is because we had a single input go on to 2 outputs. So this is not, we say, 1 to 1. We don't have 1x go to 1y in every instance. But what you can see here is that on this graph right here, at an x value of 5, we have 2 dots that are stacked vertically on top of one another. So what we can see here is this. If we have 1x, if we have an input going to more than one output, so going to more than one output, what do we notice about the graph that we don't notice over here on the right? So we say an input going to more than one output, these are kind of vertically stacked over the 5. Over here you'll notice that every single input went to 1 output. So there are no 2 dots that would be stacked on top of each other. That is, there would be no 2 y values that are stacked on top of the same x value because every x value went to only 1 output. So basically what we can draw from this is this. If we have an input going to more than 1 output, then we could say then there are dots or points that are vertically aligned, that are stacked vertically. Okay, so we'll write this out here using actually text over here, but basically the vertical line test, what it basically says is this. If you ever have a graph that you can draw a vertical line through, okay, and it only ever hits at 1 or 0 times, then it is a function. Okay, so for instance on this over here we say, all right, if every x value goes to 1 and only 1 y value, then I should be able to draw a vertical line anywhere through this relation and only ever hit it 1 or less times. Okay, but if you look again at this first relation here, we say, could I draw a vertical line anywhere? Now keep in mind, vertical lines, a vertical line goes through an individual x value. So what we're doing by picking on vertical lines is actually really saying this: were there any x values that went to 2 or more outputs? And we see that if I were to draw a vertical line right here, it would hit my relation 2 or more times. Okay. So in words, if we were to put this in words, let's go ahead and do that. We say the vertical line test. So the vertical line test. We say the vertical line test basically says this: if a vertical line can be drawn anywhere on the graph of a relation or a function, we say on a graph of a relation, and it nowhere hits the graph more than one time, then it is a function. Okay? So the vertical line test is a pretty nifty thing in testing for functions because you can just look at the graph. Okay, now I noticed that I had these right here, but we could draw some more in general if we wanted to, just really quickly before we leave off on this video. But we say, would this be considered a function if I were to draw on these sets of graphs right here? Okay, so we say, let's say I graphed some relations and I want to know, are they functions? So my first one looks like this. Let's say my second one starts at the origin. It's like a half of a sideways parabola here. We say a line. Okay, like this, a line. Maybe I'll do some points here. We say this one's got a point, 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 this one's got a point. Okay. How about these two down here? We could say a circle. I'll do a circle. And this one, we'll do a full-on sideways parabola. So we say, which of these in this set of deals here are functions? And so again, according to the vertical line test, we say if a vertical line can be drawn anywhere on these graphs, and nowhere does it ever hit it more than one time, then it's a function. So again, looking at this first one here, we say, could I draw a vertical line everywhere and there'd be nowhere where it hits it two more times? We say yes, so this is a function. This is a really nifty way of determining functions. Like this over here, I noticed that it doesn't hit it anywhere over here when I draw vertical lines, but there's never anywhere I could draw a vertical line and hit it two or more times. So this is a function. Okay, when you look at lines, lines are always functions because I can always draw a vertical line and it never hits my graph more than once. So this is a function here. When you look at this relation right here with these dots, we say, well, you know, they're all using the same y value, but that's okay. See, look. I can draw a vertical line anywhere and it never hits it two or more times. So this is a function. Okay, just to show you how easy the vertical line test is. Look at these last two. Instantly, I notice here, or even here, an x value that hit two y values in this relation here. Okay, so what we mean is this: it's a relation, but it's not a function because it fails the vertical line test. So we say fails the vertical line test, the VLT. Okay, and then over here, this one fails also because I had two y values for a given input or x value. So this is only a relation, but we say not a function because it fails the vertical line test. Cheers.